Hi everyone, it's Rui Almeida. In this video I will show you some experiments I've been working on. I'm doing some research with an architecture PhD student about object manipulation in immersive environments, and I want to share with you a demo about 3D object selection using a natural user interface, and also some ideas on how it can be implemented. Um, this time I will not be so technical as in the previous videos and will not go so deep into implementation and coding details. We will have a 3D virtual scene, and the user will interact performing gestures in real world, and those gestures will select different objects on the virtual scene. The scene will be set up on a web app that I'm developing in HTML5 and also using WebGL for the 3D presentation. For the natural user interaction, I will be using the Kinect sensor and another desktop application that I'm also developing. A desktop socket server will be sending messages to the browser WebSocket connection. These messages will send encoded information that will allow the scene interaction on the browser. It will send skeleton joint positions, and those positions will be used by the web app to select objects on a 3D scene. A 3D scene graph is usually made of a hierarchical structure of nodes and objects that result in a 3D representation of a scene. In this case, I've included a sensor node for all the real-time data and objects coming from the sensor, like user joint data or other objects in real time. When the connection to the sensor is established, the sensor node will appear on the scene. This way, if the connection is closed, all of the sensor node hierarchy will go away from the graph. In my application, the user skeleton will be represented on the scene, and it will be able to interact with the objects by pointing them and selecting them. I've used a technique called raycasting, in which we determine a ray starting on a point and following one direction vector. In this application, I have used a ray starting on the right elbow joint and following the direction vector of that goes from the right elbow joint to the right wrist joint. Now I will do a demonstration of a prototype. You will also hear some synthetic voice speaking because I have included a text-to-speech library just to make it easier to receive feedback from the scene. I'm going to stand in front of the sensor and select some objects on a scene that I have previously prepared and saved.
Environment is ready. Connection successful.
Scene 0. Cube 0. Cube 2. Sphere 5. Cube 4. Cube 1. Cube 0. Cube 6. Cube 3. Cube 0. Cube 3. Cube 2. Sphere 5. Cube 1. Cube 4. Cube 3. Cube 0. Cube 6. Cube 3. Cube 2. Cube 0. Cube 1. Cube 2. Sphere 5. Cube 4. Cube 0. Cube 1. Connection closed.
So I hope you liked, and here you have my contacts. So just send me a message to let me know about you. Thank you. Bye bye.